Hi, welcome back to this FreeRTOS series. Today we are going to learn about Mutex, which is a very important topic in case of operating systems, no matter it's real-time operating systems or not. So let's consider a scenario where there is a kernel. Kernel can be of any operating system, Linux, FreeRTOS, etc. And it is scheduling different tasks as we are discussing RTOS. So I'm talking about tasks, not processes. So it's scheduling different tasks. Let's say we have two tasks, T1 and T2. And let's say T2 is scheduled first and T2 is assessing some resource that's having some information, let's say tomatoes and written in it. So when T2 starts assessing this resource, in the meanwhile, the runtime scheduler, runtime interrupt occurs and the kernel schedules the first task. Okay, so as the kernel schedules the first task, the execution of this task is halted. Okay, and this task, the first task, is assessing another resource, not the same resource, some other resource that is having some information, let's say tomatoes written in it. And in the meanwhile, while it was assessing this resource, the interrupt occurs again. So the execution goes back to task 2, and then task 2 will resume its execution and will continue to assess the first resource. So in this scenario, there is no problem, right? In this scenario, both of the tasks are going to work the way they are expected to work. But the problem will occur when we will have a shared resource. Let's say there is a shared resource which is having some information, or not just information or any other thing, which these two tasks were assessing. And when the first task is halted or suspended during the execution, and in the meanwhile, when it was making use of the shared resource, and the control shifts to the second task and it started assessing that resource, it is possible that it affects the execution of the first task. Let's say you are writing something in an array that is being shared between two tasks, and you wrote like A, B, C, and you have to write C, E, D in that. Okay, when you wrote the first three characters, the execution is shifted to the other task and it started writing 1, 2, 3 in that shared resource. Now when the execution will come back, the flow will come back to the first task, then it will proceed from there. So the data that it was expecting should be present in that shared resource would be corrupted by the time. Okay, so in order to fix such a problem, we make use of mutexes. So what are mutexes? They are like a lock, okay, which you put on the shared resource while you are making use of that shared resource, so that if because of timer interrupt the execution of your task is suspended, no other task is capable of modifying or making change to that shared resource status. Okay, this is the idea of mutexes in a very layman's language, very easy language. Okay, so you will find the programs related to these this mutex topics in my repository. I'm going to demonstrate you the problem, and then I'm going to fix it with the help of a code example which is present here. So let's move towards the problematic code. Okay, so the link would be present in the description, so you can directly access it. Let's come here. Its font is a bit more clear. This is task suspension. Here is the problematic code. So let me explain the code first. So you have created a character array that's called my shared resource that is of 10 values. So it's going to be the shared resource between both of the tasks. There are going to be two tasks in the program. So what happens is, if you talk about the first task, in the beginning we are just initializing the baud rate. Then I created a character array and I initialized it with the correct string Hamza. Okay, Then what I'm doing is I am writing the characters present in this character array into the shared resource. Okay, and I'm putting some delay of 50 milliseconds. That is basically to bring stability. Okay, there's no other reason of putting this delay. Okay, so what I'm doing right now is I am putting the data present in this character array into my shared resource. Okay, and then after putting the data character by character to this shared resource, I am this line is putting a 0, the null character at the end of the of the string, because the strings should be, character arrays should be ended with a null character. And then I'm printing t1, a typical string to show that this thing belongs to task 1, and then I'm printing the data present in this shared resource, this shared character array. Same is the thing that I'm doing in the second task. Okay, the difference is here the data present in task message 2 is Ali Imran. Okay, and I'm doing the same thing. Okay, so it is expected that the first task should print Hamza, the second task should print Ali Imran. Okay, both of the tasks are being scheduled one after another. Okay, their priorities are same, their stack size is same, everything is same. Okay, let's make the priority same. It doesn't create any issue. The both of the tasks are going to be scheduled. Okay, so if you put the priority, give more priority to one, that doesn't matter. But the problem is, but the target is that we both of them should work the way they are expected to work. Okay, let's upload this code. My Arduino Mega is attached to the computer. Here you can see the configurations are set. Let's upload the code. Okay, so uploading is completed. Let's go to the serial monitor. Here you can see it's printing Ali Imran, but the second task is not printing Hamza. Okay, T2 is not printing Hamza. Oh, this big problem. T1 is printing Ali Imran, which should print Hamza. The second one is printing T2, should print Ali Imran, and it's printing HLI Imran. Okay, so can you identify the problem? The problem is that none of the tasks are printing the correct data. The reason is that when we were putting the data into the shared resource, the timer interrupt occurred and the shared resource is being used by the other task, and that task starts putting its own data into it, and in the meanwhile it was putting its data, the timer interrupt occurs again and the control shift back to the first task and it continues its process. So this creates a problem that none of the tasks is capable of putting the correct data into the shared resource which we are printing. Okay, now let's fix this problem. For fixing this problem, we are using Mutexes, okay, which I told you are nothing special but just the locks. Okay, so other things are same. This if block is different. This is the only thing that's added. So first I'm creating a object called xmutex, which is of semaphore handler. This is a handler of mutex. I'm creating using just one lock, one mutex, and for that I'm creating its handler. So the way to create it is you write semaphore handle underscore t and then you write the mutex name. I named it xmutex. Okay, you have to put the critical section of your code. The critical section is the section which you expect is using the shared resource. So this portion was using the shared resource, right? This is the critical section inside these inside these comments that says critical section starts, critical section ends. Okay, so what you do is first you put a lock to it. The way to put the lock is you write semaphore take mutex, and this is identifying the maximum value for which the lock would be there. Means if you don't release the lock by yourself, it's not going to be released. You may write some values here which clears it, how after how much time you want to release the lock or the mutex if it is not being deliberately left by the code. So for simplicity, I'm writing the maximum value, which is going to put the lock for infinite time, and it's going to be released only if I'm going to release it voluntarily by myself. Okay, so I did the same thing. I put the data into, first I put the lock or the mutex over the shared resource or the critical section. I put a lock, then I did the same task. Then when the task was done, means when the shared resource printed its value, then I left the mutex. And the way to do that is you write xima for give, write the handler name here, okay, and that's it. And then I put a very small delay after this, if again just for stability purposes. The same thing is done in second task. Okay, and now let's see, other things are the same. Let's see what is the result. Okay. Code is uploaded. Let's see. Excellent. So task 1 is printing Hamza, task 2 is printing Ali Imran. This is what was expected from the both of the tasks. So that is very much for this video. You will find the code link in the description and the slide link as well. If you want me to explain some particular topic related to it, please write that in the comments. Thank you very much.